very welcome to Sakshi Gopala chemistry classes. Dear student, we have dealt with so many important MCQs. Now in this series of MCQ, let's begin with question number 31. See what is the question. The percentage of empty space in a body centered cubic arrangement. Question में पूछा गया है, you have to tell in the percentage of empty space and the given structure is body centered cubic arrangement. So dear student, first of all we have to consider the packing efficiency in BCC. We know that in the packing efficiency of BCC structure, that is 68%. Okay, what does it signify? It signifies that this much percentage of space is actually occupied by the sphere. Now the left remaining space is the empty space. So my dear children, how to calculate the empty space? To calculate the empty space, we would subtract packing efficiency from 100, right? So 100 minus 68, you get the answer 32%. So the correct answer is answer number 3, 32%. Okay. Now dear students, see the next question, question number 32. We have the question, in which of the following structures the coordination number of cation and anion is same in packed structures. Okay, question में पूछा गया है, in the given 4 structures, you have to choose that one which has the same number of coordination number of cation and anion. Okay, so dear students, सबसे पहले तो देखो ये जो सेकेंड ऑप्शन में दिया है, सी हाउ टू सॉल्व दिस क्वेश्चन. इन द सेकेंड ऑप्शन कैल्शियम फ्लोराइड स्ट्रक्चर है, तो कैल्शियम फ्लोराइड का डियर स्टूडेंट्स कभी भी सेम कोऑर्डिनेशन नंबर नहीं होता है. 8:4 का कोऑर्डिनेशन नंबर का रेशियो होता है. सिमिलरली इन सी ऑप्शन Na एंड ऑक्सीजन O2 माइनस, ठीक है. देन सोडियम केटायन 8 टेट्राहेड्रल बॉन्ड, यहाँ पे भी कोऑर्डिनेशन नंबर सेम नहीं होगा. Now see alternate tetrahedral void in the crystal of zinc sulfide. This is also a wrong option, right? So see, हम देखते हैं about option number A. Let us discuss कि how option number A is the correct answer. See, whenever you are talking about the NaCl crystal structure, so that is a rock salt crystal structure. Okay, having the coordination number of 6. That means the geometry is octahedral and the sodium cations of sodium, they are present in the octahedral voids, whereas the chlorine ion, they occupy the FCC face centered cubic structure. Okay, it means that chlorine ion, they are present at the corners of the cube along with the 6 faces. It's the meaning of chlorine ion present in FCC. Now the sodium ion, it is present in the octahedral voids. Now the coordination number is 6:6. It has the same coordination number of both the cation and the anion. So the correct answer is A. Now see the next question. To get a N-type semiconductor from silicon, it should be doped with a substance with valency. So if we want to get an N-type of semiconductor, we used to dope it with group 15 element. And what is the speciality of group 15 element? It has a valency of 5. It means it has a valence electron equal to 5. So the correct answer is option number D. It contains substance with a valency of 5. Now we have the question number 34. See what is asked in this question. Total number of the tetrahedral void in FCC unit cell. FCC stands for face centered cubic cell. Okay. So do we know the number of atoms present per unit cell in FCC structure? Yes, the number of atoms per unit FCC structure is 4. We can write it as n equals to 4. Now dear children, do we have any formula to calculate the number of tetrahedral void which is present in a crystal lattice? Yes, we have number of tetrahedral voids equals to twice the number of atoms present in a crystal lattice. So if FCC contains 4 atoms per unit cell, the number of tetrahedral void is its double. So the correct answer is option number B. It has 8 tetrahedral voids. In this question it is asked, you have to choose the most efficient पैकिंग पेयर. इट मीन्स जिसकी एफिशिएंसी, जिसकी पैकिंग फ्रैक्शन ज़्यादा है, दैट इज द मोस्ट एफिशिएंट पैकिंग. सो लेट अस सी इन HCP. आई एम राइटिंग ओवर हियर. इन HCP it is 74%. In cubic closed packing or also called as FCC, face centered packing, it is 74%. Now in the BCC, body centered cubic cell, it is 68%. Now in the simple cubic cell it is 52.4%, right? So now you can choose the most efficient pair. What would be the answer? Answer number B. Hexagonal closed packing and the cubic closed packing is also called as face centered packing. In both the types of packing we have the packing efficiency 74%. So this pair is the most efficient pair of packing. Or you can say most efficient pair of arrangement in 3-dimensional. Now in the next question it is asked, defects introduced by doping. What do you mean by doping? In doping you are adding an impurity either of group 13 member or of group 15. Okay. So one impurity is caused by the presence of an extra electron and the another impurity, that means p-type impurity, is caused due to the lack of one electron, or you can say due to the electron hole. Okay, so that kind of defect, what you can say, it is a type of an electronic defect. Okay, defect which is introduced by doping an impurity that give rise to an electronic defect. Now children, see the another question. Here it is asked, the H length of unit cell in terms of radius of a sphere constituting FCC means face centered cell, BCC body centered cell and SCC means simple cubic cell arrangement respectively. इसमें आपको ये बताना है, you have to keep the values of edge length in FCC, BCC and simple cubic type. So first of all, let us begin how to solve this question in FCC, in BCC and in simple cubic cell. We know that what is the relationship between radius and edge length. In FCC, R is equal to A upon 2 root 2. Now what is the value of radius in BCC? R is equal to root 3 A by 4. Now in the simple cubic cell, R equals to A upon 2. Now calculate for the value of A. You will get in FCC A equals to 2 root 2 of R, right? In BCC A equals to 4R upon root 3, right? Similarly in simple cubic cell A equals to 2R. So let us verify the answer with the given option. We see that in the option number 1. See, the H length is given by 2 root 2R in FCC cell. In BCC it is 4R upon root 3 and in the simple cubic cell it is 2R. So we have the correct answer as option number A. Now children, in the next question we have to choose the correct order of the conductivity. means the conductivity between the metal, insulators and semiconductor. Okay, so dear children, we know that metals, they are the good conductor, they possess the maximum conductivity, and the least conductivity are possessed by the insulator, and in between conductivity is possessed by semiconductors, right? So see, in the very first option, सबसे first you see the option number C, where it is written as the conductivity of insulator equals to 0. So my dear children, कभी भी conductivity 0 नहीं होती है. It may be negligible, it may be very less in amount, okay, but it can't be 0. So this option is wrong. Okay. Now in this option number D, C, metal less than conductivity of metal, that is less than the semiconductor. This is the wrong option because metal की conductivity हमेशा semiconductor से ज़्यादा होती है. So this option is also wrong. Now see option number B. The conductivity of metal is much less than insulators. Is that true? Wrong. So this option is also wrong. Now the correct answer is option number A. So let's check. What is it? Conductivity of metal. The symbol is called as greater than or much greater than. Okay. So conductivity of metal is much greater than conductivity of insulator. Correct. And the conductivity of insulator is less than the conductivity of semiconductors. This is also correct. So we have the correct option is option number A. Now children, in the next question we have to arrange in the order of packing efficiencies. Okay, these are the given types of arrangements: FCC, BCC and simple cubic type, and you have to arrange this order in either increasing or decreasing order of a packing efficiency. So let us see the packing efficiency of FCC structure. It is 74%. In BCC it is 68%. And in a simple cubic type, it is 52%, right? So, the FCC has the maximum efficiency. See in the option number B, FCC is having the maximum efficiency. The least efficiency is of the simple cubic cell, right? And in between, the efficiency is that in between position is taken by the body center cubic cell. So, the correct answer is option number B. Now, see this question, which of the following is a network solid? Okay, you have to identify the network solid. The given options are SO2 solid, sulfur dioxide solid, then diamond. Third option is iodine. Fourth is water in the form of ice. So my dear children, we all know that diamond is a very hard, very rigid network solid. Okay, so the correct answer is diamond, right? Dear students, I am taking a few examples from assertion and reason type of question. See, first of all, let me tell you what is assertion and what is reason. Both assertion and reason are basically a statement, right? Assertion is a statement and reason is also a statement, right? What you have to tell is whether assertion is true statement or a false statement. Similarly, whether reason is a true statement or false statement, at the same time, is the reason correct or true cause of the assertion, right? Similarly, we mark our answers. Suppose that if reason is a true statement, right? Assertion is a true statement, reason is also a true statement, and reason is correct explanation of assertion. So we marked our answer as option number A. Right children? We mark answer as B when assertion is a true statement, Reason is also a true statement, but reason is not the correct explanation of assertion. Right, children? Now, we mark our answer is C when assertion is true but reason is false, as well as it is not the correct explanation for assertion. Okay. Now, we mark our answer as D when both assertion is wrong as well as reason is also a wrong statement. So, my dear children, let's solve few assertion and reason type of question which are most of the time they asked in the examination. Now the very first question in assertion and reason type of questions we have, I am reading the assertion. Okay. See what is written in the assertion. At a low temperature. Okay. It's talking about a low temperature. Particles of matter occupy fixed position and exist in the solid state. This statement is a correct statement. Why? Because see, suppose when at a low temperature, the particles, they but obviously occupy the fixed position and they exist in a solid state. Why? If agar bahar se there is no increase, there is no changes in the temperature, there is no changes in the pressure. So when pressure is not changing, volume remains constant. Okay. So even though when temperature is also not changing, the particles can't change their motion. Okay, can't change their actual fixed position. So this statement, assertion statement, is a correct one. That means at a fixed low temperature, the particles occupy their fixed position, right, and they exist in the solid state. Now see what is the reason quoted here. Under a given set of condition of temperature and pressure. Under a given set of condition of temperature and pressure, the state of a substance, it depends upon the net effect of the thermal energy and intermolecular forces. Right? अगर आप एक system में thermodynamic system होता है, okay, if you change the temperature, if you change the pressure, definitely उसकी जो thermodynamic energy है, that means उसका thermal energy होगा, that will change. उसकी जो intermolecular forces होगी, the force by which they attract each other, that will also change. So this reason is also correct and this correctly explain the assertion. So our answer is A. Reason is also, assertion is correct, reason is correct, and reason is the correct explanation for A. Now see the next question is assertion. Face-centered cubic cell has 4 atoms per unit cell. Face-centered cubic cell has 4 atoms per unit cell. Now what is the reason given? In FCC unit cell there are 8 atoms at the corner and 6 atoms at the face. So let us see. Check karte hain. See, this is a cube. Right? What it is written? 8 atoms at the corner. See, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now 6 atoms at the face. Top, bottom, side, right, front and back. Now let us check their contribution. If suppose there are 8 atoms present at the corner, so their contribution would be 8 into 1 upon 8, you will get 1. There are 6 phases, so there are a total of 6 atoms present in 6 phases. So 6 multiplied by the contribution to the cell is half. Okay. Now you get 3. And when you sum up, you will get 4. So reason is a correct one. Now assertion is also correct. So the reason and assertion both are the correct statement, and the reason is the correct explanation for assertion. So here we mark our answer as A.